Hi, so we have seen how we made the function and we have tested it also. We used it on the logistic regression. So now let us, using with the help of our function, let us now train our data set on different models. So say first we will go with decision tree classifier. Let us see. So from Scikit-learn dot tree import decision tree classifier dt underscore model is equal to decision tree classifier. Now dt underscore okay, this much is sufficient. This we have to do, and in the next step we have to pass this in my function. So here is my function, train and evaluate, and what are the two things that I had to give it? One is the model and other thing is decision model name, decision tree. So see, we have it here in just one shot. This is my model, this is my F1 score, model name, accuracy, precision, recall, and F1 score. Okay. So for decision tree it is done. Let us now do it for random forest. Simple. From Scikit-learn dot ensemble import random forest classifier. This is fine. Now rf underscore model is equals to random forest classifier. And now time to use my function. Simply I'll give my rf model, and here I'll change the name of this random forest. So model name is random forest, accuracy, precision, score, and F1 score. Okay. Third model, let us see. The third model will do it on KNN classifier. From Scikit-learn dot neighbors import KNN classifier. What I made mistake. NEIGHBORS. This is what is this saying? Oh, sorry. From Scikit-learn.neighbors import KNN classifier. KNeighbor classifier. My mistake. BOR. KNeighbors classifier. Okay. So KNN underscore model equals to K neighbors classifier. We are good till here. And now my model. Train and evaluate model name, which is KNN model, and the name of the model, means model and the name of the model. So KNN, simple, K nearest neighbor. Done. Confusion matrix of KNN. This is done. Which was this one? Third one. Let us go with SVC also. Support vector classification. Support vector classifier from sklearn.svm import svc. svc underscore model equal to svc. Train and evaluate svc underscore model comma svc. I have typed it here. Let us see whether it is successful or I made some mistake. Okay, it is a success. I got some warning, but it has executed. The model has worked. This function has worked. Nice. Let us check with XGBoost also. So from XGBoost, wait. This was the fourth one, right? 4, 3, 2, 1. Actually, see, here this is fourth, but one is logistic regression is also already there, no? We had done it. So this is actually fifth one, okay? So, and this one will be sixth one actually, but here I'll put the serial number as fifth only. XGBoost. Same thing from sklearn, sorry, from XGBoost. From XGBoost, import XGB classifier and XGB underscore model equals to XGB classifier. Till here it is good. Simply copy the model, means execute the definition. XGB model. Here you can write as XGBoost. It is done. Classic confusion matrix of XGBoost. Accuracy is 59%, precision, recall, and F1 score. Now let us see model results. See, I have logistic regression. It has been done twice. It has happened twice because I think I have executed it twice on that logistic regression. Decision tree, random forest, KNN, XPC, and this XGBoost. So I will make this as a data frame. So result underscore df is equals to pd dot data frame model underscore results. Show me result. See, so we have a very beautiful data frame which is giving us all the models. This logistic regression, as I told you, it is coming twice because I had executed it twice in the beginning. So I am having this here. See, all the models are there: accuracy, precision, recall, F1 score. So I can compare it. Just by looking at this, my first conclusion is that, see, logistic regression and SVC, they have given the best performance. Random forest, decision tree, random forest has performed better than decision tree. But see, now logistic regression accuracy is good and precision recall. So these are the values. So this is how you are doing it. You have to do. Okay. Now there is one more final step that I would like you to see, which is actually it would be step 13 or something. We'll just see it here only. That is the concept of feature importance. This we want to see so as to get an idea that which feature contributes most for the prediction of this heart attack. It helps us to identify which features it contributes most to the prediction. Okay. So actually this is very important. So let us see how it is done. It will be using random forest. So feature underscore importance is equals to pd.dataframe dictionary. Now feature will be my x dot columns, and importance, this is the main thing. Rf underscore model dot feature underscore importances, this is the one. Let us sort it by ascending or descending order. Dot sort underscore values by importance, and ascending is equal to false. Let us see the feature importance now. I would like the top 10. Not like this. Dot head. Simply do head. See, so these are the 5 features that are contributing most. These are having the most. See, and it relates with the. See, it is a synthetic data set, but if you see it, it relates with the general observation also. Income, exercise hours per week. See, income is putting more it on the. It is contributing more on the prediction. But yeah, so that's how it is. So with this we will conclude our project. uh, I do hope that you got a lot of things to learn here, and it was a good practice. Dataset was simple, and see, the more we practice, the more we get strong into it. Means the more we practice, more the silly mistakes will be reduced. Okay. So thank you for watching this video, and let's see.